Advent of Code 2023, day 10. All right, I'm going to skip over this as quickly as possible because I don't have a lot of time today, unfortunately. So I see a hang glider, I see hot springs, alien landscape, flowers of trees and made of metal. Discover the entire field of Standing is densely packed with pipes. Okay, so it's a pipe problem. You make a quick sketch of all the surface pipes you can see, your puzzle input. Okay. Good thing I'm good at sketching. So you have vertical pipe, horizontal pipes, 90-degree bends. Okay, I kind of see those 90-degree bends there. S is ground and S is the starting position of the animal. What animal? I skipped over stuff, didn't I? I missed out on whatever the animal was. I'm not going to care about the animal right now. I'm too much in a rush. Square loop of pipe. Oh, I see. Okay, yeah. So F, then, okay, so we can move around here. If the animal had entered this loop in the northwest corner, the sketch would instead look like this. All right, so S is where the animal enters the pipe loop. And the diagram above, S tile is still a 90-degree F bend, but you can tell because of how adjacent pipes connect to it. Oh, okay, so that's going to be problem number one, is figuring out what pipe type the S is. There are many pipes that aren't connected to the loop. This sketch shows the same loop as above. Okay, but all the ones on the outside and the 7 in the inside is not connected. Okay. In the above diagram, you can still figure out which pipes form the main loop. They're the ones connected to S. Okay. Got it. Every pipe in the main loop connects to its two neighbors, including S, which will have exactly 2 pipes connecting to it. Okay, so maybe this is a clue that we don't have to worry about making the loop and then figuring out, if this 7 had been an L, then an S would have been connected to it, but this is going to guarantee there's only 2 connected, this east-west one and this north-south one. Okay. Here's a sketch that contains a slightly more complex main loop. Here's the same example sketch with the extra non-main loop pipe tiles also shown. Okay, I think I understand what we're doing here. If you want to get out ahead of the animal, you should find the tile and loop that is farthest from the starting position. Okay, because the animal is in the pipe, it doesn't make sense to measure this by a direct distance. Instead, you have to find the tile that would take the longest number of steps along the loop to reach from the starting point, regardless of which way around the loop of the animal went. Got it. Understand. 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 Okay. So we have a couple of example inputs. This one says 8. It's just symmetric, right? 1, 1, 2, 2, 3, 3, 4, 4. So I could just write a little code that goes all the way around and then divide by 2. Because this is 4 and this one's 8. Is that cheating? If there's an odd number of tiles, then we just need to round up when we divide by 2. All right, well, let's get the input. There it is. It's very wide, apparently. There it is. This is just the first few lines of it. It's 140 rows, apparently. All right, so we have to figure out where the S is. Let's take a look and see where the S is. There it is, right there. So we can see that it's connected to an L here and an L here. It's not connected to this vertical pipe next to it, and it's obviously not connected to the dot above it. All right, so we just have to figure out, we have to write a little bit of code to figure out which way it's connected. All right, that won't be too bad, I think. Let's start with the usual kerfuffle. Creating another one of these things. Okay. Oops. 10. 10. Day 10. Create the file. Go to it. 23, day 10. And come on. There we go. All right. I guess step 1 is create the grid, right? It'd be a hash map of point to tile, and we have to make a tile. Enum tile, and there's 6 tiles, if I read that correctly. I guess we can add this one as well as a nothing tile, and we could ignore this and just save it. So we have north, south, east, west, northeast, which is the L, northwest, I'll put the comments in a second, southwest, and southeast. Keep doing that with the O's. Okay, so this is a J, this is a 7, and this is an F, and then I'll put in a nothing, just to round things out. This is east-west, and this is north-south, like that. There we go, nicely formatted. And let's pull hash set in. Parse. So let lines equals AOC lib read lines input 2310.text. And now we're just going to shove everything in the grid, right? So we're just going to loop over the grid and put everything in there. I'm going to put in the nothings. Generally, I don't. I think it might be easier because I'm thinking of making a quick little thing on grid to be able to return. Yeah, generally I don't. Let's not do it. I can always add a get function here. Yeah, I'm just trying to think. Sometimes it's just easier not to deal with options. And whenever you do a grid get, or hashmap.get, it returns an option. All right, let's cross that Rubicon when we come to it. For row line in lines. Do I have to say iter enumerate? Yeah. And then for call ch in line chars enumerate. Self grid insert row call. Yeah, see, this is why I wanted to have the nothing, so I could just do this one statement here. Let's do it. Comma match ch. Oh yeah, maybe we don't want to do this because when we hit the S, we're gonna have to figure out what tile to stick in there. Let's do this. Let start pause equals none. Make it mutable. And then I'll just stick a nothing in there for now, for when we hit the start position. So this is what I'm thinking. We'll just set start pause is equal to some row call, right? But then we need to return a nothing. Because that's what we're doing. We're inserting into the hash map right now. So this becomes the north-south. Let me grab these. Get rid of these things and just put on X tile colon. There. And now this east-west is this, northeast is the L, northwest is the J, southwest is the 7, and southeast is an F. All right, we're good. Okay, so I think we have a grid. We just need to figure out the starting position. I mean, we have to figure out the starting position's tile. Oh, everything else is nothing. Yeah, see, I think this nothing thing, normally, I mean, in previous years, what I did was I just didn't insert into the grid when there was a space. But I think that's when I was using hash sets instead. What do we got? We got a oh, yeah, I'm so used to putting ampersand. Oh, right. Okay. Okay. And now we need to figure out what the start position is. Let's see if we found it. $42.25. I assume that's correct. Let's take a look at the input. And we're going to be off by 1 because this starts at 1, right? So 43.26 versus 42.25. So I think it's correct. All right. That part has been completely debugged. We now have a thing that we need to figure out the starting position of. Does it go in part 1 or does it go in the parse? I'll put it here in the parse. We need to look at all the tiles around it. All right, for dir in, let's say north. East would be 0, 1. South is 1, 0. And west is 0, -1. And then we have to put together what tiles we have. How do we figure this out? I guess we need to know the direction we're looking from. All right, so we're gonna make it a direction enum. Neat. And I'll put a copy clone on these guys because I imagine we're going to need those, and partial equal because I'm going to want to compare them. There we go. So I think actually I want to do it this way. I want to say let north equals self grid get start pos dot 0 -1 start pos dot 1 unwrap or default. And we're going to stick a default on this guy. And let's just see if we got that. Println north. I forgot what tile it was. Oh, right. Let some start pos equals start pos, otherwise panic. Bug in your code. There. Tile default is not satisfied. Oh, ampersand tile default. I had this problem before. That's so annoying. Impl default for tile. Then default tile. I think we can just return tile nothing. Like this. Static. Yeah. Okay, so now we have that, and north is nothing. I think that was correct, right? There was a dot above us. Let me pull up the thing in here rather than in my text thing. Insert. Should I translate from Maltese? S. There it is. Yeah, nothing was above us. Okay, so let's get the other directions, right? And I'm gonna be a little less pedantic about this. Fn get self row call, right? And that way I can just do it here, and I think that'll help simplify the code because I'll be able to say self get right? Oops, I can just do this. I think that'll make my life a little bit easier. And then just put these up here, self grid get row call, unwrap or default, and deref it to return it. I think that'll work. All right, we still got nothing. That's good. Let's do south. Come on. Plus. Wow. Oh. South. But it's showing northeast for south. Is that right? Yes, that's right. L is northeast. Okay. Let's do the rest. South, east, and west. So this is +1 here, and then west is -1. Nothing, northeast, and then east of us is a north-south, and then west of us should be a northeast. Let's see if it is. Perfect. Okay, so we're able to at least determine this information. Let's make that go away. Now we have to figure out what tile are we on? How do we do this? Devothman, thank you for the follow. Let's see. Ooh, and Gratis Victory, thank you for the follow. Let's see, how do we figure this out? If we have, oh, you know what we should do is write a little can go. I'm going to write a little can go on this guy here. On direction, no, on tile. FN can go, right? And we take a self and a direction, and this returns a bool. So saying, if we're on this particular tile, can we go in this direction? And that'll help us figure out, you know, if the north tile can go south and the east tile can go west, then it must be a northeast tile, right? Mohad says, right, what? A Kengo. You've never heard of Kengo before? So this is just match self for all the tile types. What we can do is, if it's a north-south, then we'll return true if we can go north or south. Right, let me just grab this here so I can type more easily. Come on. North, south. Right? If it's east-west, we have to do the same thing here. So if we have a northeast tile now, which directions we can go are north and east. And if this turns out to be only useful for figuring out your sorting position, I'm going to be sad because this is a lot of typing. Here's southwest. Let's do southeast. And if you're on nothing, we're going to panic saying shouldn't be looking here. Don't panic. We'll just say false. Oh, I missed something. What did I do? Oh, there's a comma there. There we go. Wizard says do match self comma dir. Yeah, but then that would be I was going to say that's 24 of them, but that's not true because how would that look? Let's see. So it would be match self dir, right? We'd say tile north, south, right? If I could type direction north, that's true, right? And then we could do the same for all the others, right? Will this actually fill in the match arms? Wow. Oh, that's why I have a northwest. Did you see that? Let's fix that. There we go. Oh, Mizu says you can combine them that way. Okay. Should not have copied that, huh? Is that cleaner? I guess. We should be able to pull all these up here, right? Oops. Like this, and like this. And we change this. Like that. And just put all these as true. And then everything else is false. How's that? Oh, I put a G in here. And I got this typo to deal with. Okay. Yeah, I think that's what they were. I have to pull up my my puzzle input again. North was nothing. Oh wait. Oh yeah, it's because it's wrapping. North is nothing. South isn't. No, east is a northeast. Is that the way I did it? North, south, east, west. Okay. So this is a northeast. And then east is a north, south, and west is a northeast. Perfect. Okay. So I think it's still working. All right, we have something now. And now we just have to we need to figure out whether or not we can go in the various directions. Can go direction south. And then we just need to change all these. Can we go north from there? From east, can we go west? And from west, can we go east? And only two of these are going to be true, right? And let's see. We have a false, true, false, true. Perfect. So now, oh darn, now it wraps. Will that help with the wrapping? And we can just match N, S, E, W. Oops, like this. Oh, I changed these to single letters so that I was hoping it would go in one, stay on one line, but I guess I'm stuck. Okay, so match north, south, east, and west. So if we can go north. Oh, no, we can come from the north. And we can come from the south. Then these have to be false. And false. That means we're on a north-south tile, right? If we can come from the north, we can't come from the south, but we can come from the east. Then the tile we're on, is it that simple? It was just a northeast tile. Yeah. True, false, false, true. We have a tile northwest. Now we just bump it down, right? False, true, true, false. This is tile southeast, false, true, false, true. Tile southwest, and false, true, false, true, true. Tile east-west, right? And anything else is a north, south, east, west does not have exactly 2 directions. All right. Let tile start tile is this. Okay. And we got a panic. False, true, false, false. Uh-oh, did I break it? I thought it was working before. Oh, I didn't undo too many times. It should be east. There we go. So now our starting tile is what? Is it southwest tile? Yes, it is. Look at that. Because L, and then this would have to be a southwest to go to that L. Perfect. Okay, so at least for this one case, I have it working. So we're just going to shove that directly into the grid. Grid, insert, start, pause, start tile. All right, now all we need to do is run around the maze. For part 1, we run around the maze starting from the start position. Actually, it doesn't matter where we start. And then we just run around the maze and then count how many steps we took, divide by 2, and that should be the answer. I might have an off by 1 on there, but we can try it out with the test input first to make sure. Okay, part 1. Let mut steps equals 0. And then we'll just change this steps like that. There we go. I don't know why that took me so much time to figure out. Okay, so let mut cur pause is equals to self. Oh, I didn't save the starting position. Let's do that. Okay. So we have the current position. Now we just need to figure out which way we want to go. I can't just pick a random direction because the starting position might not go that way. Sabin, thank you for the raid. Welcome, and welcome raiders. So if we just pick a we can use the can go again to pick a direction. And just pick the first one that works. It doesn't matter which direction we go around in. Const durs is direction 4. Right. That. This gives us all the directions. Sadaliman, thank you for the follow. All right, now we just find the first starting direction that we can go. Let mut cur tile is equal to self get cur pause 0, cur pause 1. All right, this gives us a tile. Now we can just loop over all of the tiles and figure out which direction we can go. Oh, Sabin, thank you. Thank you for the follow. If, let's say let mut dir equals, oops, I guess we can just start it off as west. See what happens. And we're going to assume that one of these is going to work. If cur tile can go dir, cur dir equals dir break. How's that? Println, we can go dir from cur tile. Cur dir from cur tile. Oh. There we go. We can go south from southwest. We certainly can. So we're going to go south. So now that we've got our current direction and our current tile, we just need to walk around until we reach the start position again, right? So what we'll do is we'll take one step. How do we want to do that? Cur pos is equal to, we do need to know which way things are, right? And so I can have const delta, which is going to be I64, 4. And it's going to be the same order as this, so we can just look it up using the dir, right? The cur dir variable. So north is going to be -1, 0. South is going to be 1, 0. East is going to be 0, 1, and west is going to be 0, -1. And if it's on one line. Okay. So we can say, oh, that was a mistake. Cur pos is equal to cur pos. Oh, we have to say of 0. Yeah, so let delta equals delta of cur dir as usize, right? And now we can say cur pos is equal to this plus delta 0, comma cur pos 1 plus delta 1. And we'll be able to use that through the entire thing. And we can say while cur pos is not equal to self start pos. And we've already gone one step here. So I should set steps down here to 1. We'll say steps plus equals 1. And then these 2 lines. And we output the steps. And then that died because I put a, you know what, I'm going to put a underscore in there. And we got an infinite loop somehow, which is great. That's always what I wanted. All right, let's kill that. Yeah, this should complete pretty quickly because we're just stepping around the thing. Let's use test input now. That's what we do when we fail. Do that. Test input. Make sure I don't have any already. Good. Test input. So we'll just grab this here. The complex one. Yeah, the complex one. Paste. Like that. That looks good. And now we could do is print out the location as we step through them. Cur pos. There. We are getting a warning. Maybe the warning is related to what I'm doing. I'm not using the current tile. Oh, yeah, duh. I need to figure out which direction I can go after I get the tile. Oh, that's dumb. Okay. So we use the current tile to figure out which direction we can move. But after we do the move, we have to get the new current tile and figure out which direction to go. So I'm going to write a little next on that. Self get cur pos 0, cur pos 1. So we can say now cur dir is equal to cur tile dot next of cur dir. And this is what we need to do down here. And I got to write next. Oops, what happened there? Somehow I lost my closing brace. There it is. Right, and now I just need to write next on for tile. And that'll tell us which direction we go after we come from a certain direction. Next self direction. So this is just a simple match, self. Okay, this is going to be interesting. I guess we could do the same idea here, where you match them both. And then ignore the ones that don't make any sense. If we went north on a north-south tile, then we can continue north. If we're going south, we're doing south. Oh, this is still wrong. Okay, there we go. This should never happen. We can't be going east on the north-south tile. We can't go going west on the north-south tile. So these are going to end up being here. Going dir on tile type self. Like that. Okay. The same with these two. East-west on north-south tile doesn't make any sense. So let's get rid of those. If we're going east, we continue east. Come on. I'm going to copy that. And if we're going west, we continue west. If we went north, we can't go north onto a northeast tile. If we came from the north, if we're going south and arrived on a northeast tile, then we're going to go east. Okay. This is going to be tricky to get right. We can't go east this way. And then this one, if we went west, now we go north. Okay. And we want to see a pattern here. For northwest, it's the same thing. Can't go north to get onto a northwest tile. You can go south on a northwest tile and we go direction west. You can't go east, but you can be coming from the west and then you go north. Okay. We'll get there. This is tedious, isn't it? Southwest. You can't be coming north from a southwest. If you're going from the south, then we're going to go west. For southwest and east, then we go south. Wait, no, southwest, you can't come from the east to do that. Let's go blow that away. If we're going, oh no, that's right, because we're going east and we came to this tile. We can't be going west onto a southwest tile. Got it. Now southeast. You can come, you can't go north from there. You can be coming south, in which case you're going east. You can't go east onto it. And if you went west onto it, then we're going to go south. And the nothings go away. All right. So this actually built. Let's try it out. It panicked, going east on tile type northwest. Yeah, northwest, you should be able to come, you should be able to go east. Okay, so I got that wrong. Right, if you're going from the south, you can go east. If you're coming from, no, yeah. Oh boy, all right. Let's print it out this way. Cur tile corridor. This is the the fun part of this puzzle. Yeah, if you came, this is the direction you came from. Oh no, the direction you're heading. This is the direction you're heading, and you hit a northeast tile. Then we want to bend to the east. Okay, so let's see what this says here. We're position 30. The tile type is north-south, so we're going to be going south. At 40, and let's pull up the test input. Oh, yeah, so we started here, and we're on the north-south. Now we're going south. So now we hit a northeast. Wait a minute, what am I doing wrong here? We do want to go east, but then we want to be on the next tile. It's failing here. So we're going to say next position is this. Next tile is this. All right. So the next position is 4-1. Row 4, column 1. Really? 1, 2, 3, 4. Oh yeah, right here. And we're on a northwest tile. And we just came from the, oh, we were going east. Yeah. So if we're going east, we want to go north now. So I have to fix all of these things up, huh? Northwest tile, and we're heading east. And we want to go north. Let's see if we can separate all these out and make sure they all make sense, right? These make sense. If you're going east-west, you're going east-west. Northeast and you came south, you want to go east. Northeast. Oh, you want it coming from the west. Okay. Then we go north. That makes sense. Now northwest tile, going south. We want to go west. For the northwest tile, we're going east. We want to switch north. Okay. Southwest. We can see here, southwest, southeast. So if we have a southwest tile, we can't be coming from the south. We have to be coming from the north. And southwest tile, if we're going east, then we go south. That's right. So this should be also northwest. Okay. I think everything lines up now. We got a lot more output. 16. And what was it supposed to be? For this complicated one? 8. Oh yeah, so if we divide by 2, I think we have it. Let me get rid of these printlins. I don't need those. And this gives us an answer in steps, so we wanted to say steps over 2. Should we try the first one? Let's try the first one just to see. I want to try the first one with the complicated thing here. So we're going to say cat into test input 1. I guess we can move the other one to 0. Test input, there we go. Let's say 1, and it should be 4, right? Okay. Should we try my input now? Do we have enough to trust ourselves? I think so. Live dangerously. 7173. Seems long. Oh, it's the right answer. How about that? Okay, so we have something that works for part 1. And what are we doing wrong here? Match expression looks like matches macro. So it's saying instead of doing this, it's saying change it to a ginormous matches macro. That's hilarious. And what would be the advantage of doing it that way? I think it's probably complaining because of these are all trues, right? Versus false. It is like very much like a matches macro, I think, but I think this is a lot easier to read than this blob of text. I'm going to paste this in here and see how it formats, how Rust formats it. It's not, oh, it's not formatting because the this is all messed up. There, does that work better? I don't know. That seems to be formatted well. Yeah, I'll take it. Let's see if it still gives us the right answer. 7173. Yeah, that sounds right. It's Mohad. Yeah, it's almost like Haskell-ish with this kind of thing here, but that's all right. Git status, git add source, git commit -m 2023 day 10 part 1. Mohad says I try to decrease the matches in part 1 as much as I can. Okay. I mean, this is. Oops, I got the wrong file here. There. Tried to find patterns. Yeah. I mean, it's northeast is north and east, southwest is north and west, southwest is south. So it kind of writes itself, unlike this thing, where you see my failing brain fail to brain. All right, let's see what part 2 has to offer. People saying this is hard. You quickly reach the farthest point of the loop, but the animal never emerges. Maybe its nest is within the area enclosed by the loop. To determine whether it's even worth taking the time to search for such a nest, you should calculate how many tiles are contained within the loop. For example, this. The above loop concludes. Oh, God, I don't know how to do this. I mean, I know like the general case of how to. Here's the same loop again with the regions marked. These are outside because you can get in from the outside. Okay. In fact, there doesn't even need to be a full tile path to the outside for tiles to count as outside the loop. Squeezing between the pipes is also allowed. Oh, man. Oh, God. How do I going to do this? Now we have a larger example showing there's only, what, 6 here? Oh, 8. There's 2 more over here. These are outside the loop, right? Okay. And this is a fully connected version, or a fully specified version with. Oh, I see here. Any tile that isn't part of the main loop can count as being enclosed by the loop. Okay. So even though there's junk over here that's not connected to the loop, it still counts as in the loop. Right? We have 7 IIIL. Where is that here? Oh, I guess it's a different example. I was trying to compare it to this one, but it must be a different example because this is L-J outside L7 II, and I see L-J here. So this must be a different example. Here are just the tiles that are enclosed by the loop marked with I. Oh yeah, so this is a different example. Got it. In this last example, 10 tiles are enclosed by the loop. Okay. So, I mean, I generally know the idea of what to do. One thing we could do is try to do like a flood fill of the outside and then count how many remaining tiles are, right? I'm thinking first what we can do. Let's visualize this. Let's just start up by visualizing it and see what we get. Self hash set. Oh no, self visited insert curve pause. All right, we'll do that one and we'll do that one. And then we can print it out. Actually, if we're going to do that, we don't have to do this mess. Right? We could just do this. And we don't even need to keep track of steps. Did I check this in for part one? I don't think I did. Let me undo all of that stuff because that's all. Oh, I did. I did commit it. Okay. All right. Because here's what I'm thinking. If we have a visited thing, that keeps track of the count for us. We don't need to have a separate steps. We can just say self-visited len over 2. And then every time we insert into the current position, we can do this as a while not self-visited cur pause. Get rid of that line. And the first thing we do here is say visited insert cur pause. Actually, we can combine these. Right? This is Minips. Welcome. Thank you for the follow. Kai says, yeah, part 2. I had to take a break. Thought I had figured out, but the joke was on me. Okay, well, let's see what I can do here. We still get, okay, so after all of that hackery, we still have 7173, which is good. That means I did that right. Now the thing is, we can print everything out. Oh, except I don't have a min and max. Let's save those. Let upper left. Let. What am I doing? 64, 64, and lower right. Actually, we could just do it this way. Size. We're just going to use 0. Oops. We're going to just use 0, 0 and live with it. And then we can just say here, let self size is equal to lines of len and lines of 0 len. Right, and now in part 2 we can print this out. For row in 0 dot dot self size 0, for call in 0 dot dot self size call 1. That'll format. Print, bang, and I'll impl display self get row call. Right, and then print len. Right, and now I'll just impl display for tile. I forget where it is. Standard format display, maybe. Standard format display. Okay. And then this is just right bang F of this. And we're just going to match on the tile. That. There we go. Great Valor King says, after reading part 2, I went to the gym, and after 2 hours, I still didn't have a clue. Well, I'm streaming, so I'm going to have to come up with a clue somehow. Notice how I'm stalling by doing a totally unnecessary... I'm thinking in the back of my head how to do it, but northeast is that guy. Northwest is J, right? Southwest is 7, and southeast is F. Nothing is a dot. All right, so this should print it out now. Look at that. Oh, right. And the whole point of doing the visited thing is because I only want to print out the parts that are visited. So if self visited contains row col, right? Then we'll print that out. Otherwise, print a dot. And that way we can see, yeah, see, it's a lot less. I'm going to widen this out here. Right? So this is what it looks like when we just consider the path that we took. Great Valor King says, a colleague shared his idea. It seemed nice, so I implemented it, but all the explanations on Reddit weren't clear to me, so I didn't even try to do them. Well, I'm not going to go to Reddit just yet, because that feels like giving up. The thing is, so what? Here's the way you normally do. Like if you have a curve, can I do this? Isn't there like a sketch, online sketch pad? Yeah, I did this before. Ugh. Yeah, I did this before. How do I clear that? New. There we go. Color. Go. How do I say go? Create. There it is. All right, so if you have this random curve, right? It looks like this, which is essentially what we have. Is there a way I can draw lines? I guess not. So just pretend this is a straight line, all right? We're doing a straight line there. And you can tell what's inside the curve and what's outside the curve. And this is one way to do it, right? You know, the other way is, you know, you have, like I said, flood fill the outside and then count up everything that didn't get flood filled. Code Monk. Hello, haven't seen you in a while. This is like using, I forget what it's called. But basically every time you cross the border, now you start counting pixels are inside. You cross the border again, you stop counting pixels. Cross the border again, you start counting pixels, and you cross the border again, you stop, right? Great Valor King says sweep line, maybe. I don't know. I don't know it off the top of my head. There's also another algorithm that I know of. Grants. Begins with a G. And that also will allow you to determine what's inside and outside and the way it works is you pick a point that you know is, and you pick a point where you know which direction is inside. So if you pick you like this thing here, you scan until you hit a point. Then you know the point to the right is inside. And then you do basically a flood fill of that from that point. And then you go to the next point. And you keep looking to the right. You keep looking to the right. And then for our case, we have straight lines that go like this, right? And over like this, and up like this, and down like this. So we have this kind of a shape, right? We could use scanline, but I don't know how to do that because of this mess, right? Or we could do this, whatever it's called, where you look to the right, and then as soon as you turn the corner, now you look down. You turn the corner again, now you look to the left, right? That kind of thing. and you keep doing a flood fill every time you find an empty point. And then once you're done, you add up all the points that you flood filled. Right? Because I don't know if we just did a line at a time here. Code Monk says counting for the corners are a bit tricky. Yeah, that's what I'm finding here. Because right, if we just did the line across, right, we could say, okay, we're entering, this one here means we're entering. This one here means we're leaving. So now we know that all these points are outside. And then we enter again, and then we leave again, and we know these points are outside. And the reason we know these are inside is because we entered, and now we have an empty point. We have an empty point there, and then we leave again, and now we're outside. But this is the thing here, right? With this business, right? We have to know here that we're outside. So we know that we went inside at that point, and then we have to figure out, oh, this means we went back outside. And then this would mean we went back inside so that we can count this as going back. This last pipe is going back outside. I wonder if this is the only case we have to worry about, right? If we look at this, right, this is L then J, and we start outside and we stay outside. Here we started outside, we went inside, and then this L to 7 means we're going back outside. Is that always true? And then F to J means we're going back inside, or we're flipping the direction. Sorry, I shouldn't say going in one particular direction. This will flip the outside inside flag. This will flip it back. This will flip it the other way, and this will flip it back. I don't know if that'll work though. Walker Code says, could you ignore the horizontal pipes along the path and treat LJ as vertical pipes? Yeah, except you mean this would be flipping it from outside to inside, ignoring these, and then flipping back outside here? We could try that. Then this would flip it inside, ignore these two, and flip it back outside. If we did that here, oh no, that wouldn't work for this thing here, right? We'd have to say this is going inside, then we'd say, okay, I'm going to flip it outside, ignore this one, and flip it back inside, and then that wouldn't work for that case. I think it's only when it's vertical, right? So this is F to L to 7 to J is quote unquote vertical. So this is kind of a vertical line. So if you see an L to 7, that means it started off at the north and is continuing to the south. So I think that should count, right? And then the same with F to J. F to J meant it started from the south and is continuing to the north. Whereas L to J means it's turning around. So, and then F to 7 means it's turning around. And S is F in this case here. Wizard says inside, inside, above, inside, below, and outside. Ooh, that sounds really complicated. Mohad says outside's vertical bar inside, L outside. Yeah, except I bet you I could come up with a case where L doesn't switch to outside because of this situation here. Right? If we did this, I think if I started an L and ended a 7, or started an F and ended a J, then that should count as a flip a bit flip. And the vertical bars should count as bit flips. Right? It's this combination of direction changes, not just the L or just the 7. Now I'm going to look up, what was it, Grant's algorithm? Nope. Green's? Green algorithms. Green's algorithm. Oh, Green's function is an impulse response of an inhomogeneous linear differential operator defined on a domain. That's definitely not what I'm looking for. Yeah. Inside curve algorithm. Using the scanline method. Yeah, okay, that's what it was called. But what other algorithms are there? File, list of. There's a seed fill algorithm, right? And the scan. Okay, but that's not what I'm looking at. I could have sworn there was something else for. I can't remember. All right, I'm going to try the scan line. Mizzard says Green did a lot of vector calculus. Okay, so I must be thinking of some other dude. Benny Yamas. Thank you for the follow. Welcome. Walker Code says I implemented using a scan line, ignoring F's and 7s. And now I'm wondering how that worked. All right. Well, I'm going to try it using, I'm going to comment this code out because I might want to see it again for the small examples. And what we can do is we can try one of the test inputs. This one gives us 4. Okay, I'm gonna put this back in so I can see which one we're dealing with. Yeah, okay, so this is a little guy. So it's, oh, part 1 is 4, yeah. So this should give us an answer of 1. And I think it will, just the basic scanline algorithm will. So let's take a look at a more complicated one. Yeah. Okay. That's why. That was just the pipe filled in one. Let's do the one that says 10. That would be a good one. Not that, because it has all the I's in it. Okay. Right. And then, oh, why did I say 3? I think I skipped 2. That's all right. All right, so this is what it looks like. This is what the file looks like. Right? And this is the pipes that we found that we actually traveled through. So we can see there's a bunch of ones here, and these are clearly outside. So we just need to be able to do this. All right, I'm gonna get test input 0 working first. That one's complicated enough. Walker codes, thank you. Walker code says because F horizontal after scanning left to right and 7 is horizontal before transitioning left to right. That's for your algorithm. Okay. Well, I'm gonna try this thing that's been rattling around inside the back of my head here. So again, we're going to use the self-visited to determine whether or not we should look at the tile, because there's a lot of junk that we don't have, we want to ignore. So we'll do the scanline thing. Maybe I could just do this as I'm doing this, right? So if it contains this, we'll say get it. I'm going to have it separate, actually. I'm saying we're just repeating all this code without the prints, but I'm going to separate it because I'm going to delete the print code in a second, or as soon as I get this solved. So match, no, let ch equals self get row call, right? Match ch. And if it's a vertical bar, we're going to flip our bit. Let inside equals false. Right? We start outside. And so this becomes inside equals not inside. Right? Tile east-west gets nothing. Now the question is, right, I was going to go here to take a look at what's going on. If we start at an L and end in a J, or start in an F and end on a 7, then we don't change anything. But if we start on an L and end in a 7, or start an F and end in a J, then we want to flip the bit. So if we say tile, and this is an L, which is a northeast tile, then we want to set a thing saying we're doing a northeast. Maybe what we can do here is let my tile is equal to tile nothing, right? And then just say here tile is equal to ch. And the same thing on the F, right? So tile southeast and then if we hit a 7, we want to see was our previous tile an L, and if so, we flip the bit, right? Tile, if it's a 7, which is a southwest, if tile is tile L, which is northeast, then inside equals not inside. Is this going to work? And then finally we have our southeast tile, which is this F. Oh no, we already did that. Northwest tile. And the northwest tile is the J. So if the previous one was an F, like that, inside equals not inside. Is that going to work? And then this is the else condition here. If the visited does not contain it and we're inside, then we want to increment our counter, right? Code Monk says it should definitely work. Okay. Oh, what did I do? Oh, right. I'm treating it like a set here. And we're missing the tile nothing. If we hit a tile nothing, that's a bug, right? We should never have a visited tile in nothing. 1. Is that right? For this, oh, we don't know for that guy, right? But I have test input 3. Ooh, look at that. It came up with 10. Right, first try? That would be amazing. I'm still dumping this out, but 291. That seems low. Haha, how about that? That's crazy. Okay, so I was able to figure out the inside versus outside thing, right? Because this is the vertical line. And so this gets treated like a vertical line, a single vertical line. And the same with the FJ, still gets treated like a vertical line. Whereas LJ or F7 do not, right? And those are the only two patterns you can have. You can't have a 7 dot 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 F because then you're not connected.